interoperability session, just for those just coming in, make sure you're in the right place. And the first speaker is Diego Scardacci from EGI, who co-chairs the TIDS Task Force and the EOSC Future Technical Coordination Board. So he's going to speak to us about outcomes of the EOSC-Association Task Force for technical interoperability of data and services. Thank you.
Thank you very much, Jonathan, for the introduction. I hope my slide will appear.
Can we have the first slide, please?
Okay, very good. Thank you very much. This presentation will be a summary of the main achievement of one of the EOSC-Association Task Force, a task force on technical interoperability on data services. This task force is, I would say, a really technical task force. Is dealing with everything about EOSC technical architecture, interoperability framework, infrastructure, what EOSC should deliver from an infrastructure point of view, and so on. I'm co-leading this task force together with Eva Shaka, that should be also in the room. Eva, are you around? Oh, maybe? If not, she will come for sure. The task force already produced a deliverable. It's about the design consideration of technical interoperability in EOSC. It's deliverable to describe some high-level concept about how to achieve technical interoperability between services and dataset. And there is another deliverable that is almost ready. We are waiting for the final validation from the reviewer. That is a landscape overview of the EOSC interoperability framework capabilities and gaps. This is a document that will give you an overview of the work that has been done until now around EOSC technical architecture and interoperability framework, and also provide some recommendation on what the EOSC interoperability framework is. Okay, I think you know this picture, since the EOSC node is the hot topic in these days. I'm using this picture to explain you what the EOSC interoperability framework is. You can see we have this network EOSC node. This is a picture coming from one of the presentations of the European Commission. The EOSC interoperability framework defines the interfaces that allows nodes to communicate. So if there is a communication between two nodes, this happens with the interfaces that are part of the EOSC interoperability framework. The EOSC interoperability framework provides a flexible framework of interoperability guidelines. The interoperability guidelines are documents that describe how two services, or more in general, two EOSC resources can interoperate, providing instructions, describing the interfaces, and explaining step by step what is needed to make two services and two resources in general to interoperate. This interoperability guidelines supports the interoperability and composability of resources in both the EOSC core and the EOSC exchange. This is a definition that is coming from EOSC Future and that was blessed in the context of the task force. Coming back to the previous diagram, I told you that the interoperability framework defined the interfaces that would allow the different EOSC nodes to communicate. So we can also say that the EOSC interoperability framework empowers the EOSC federation model. So if you are looking on how to register and integrate resources in EOSC, you have to look within the interoperability framework, where you can find all the instructions to federate your services within EOSC. The deliverable that I mentioned earlier, the one that is will be published in the next days, starting from the work that has been done in the interoperability framework in the different implementation projects, and in particular in EOSC Future, developed 9 recommendations to establish and implement the EOSC interoperability framework with the aim to enable service and data composability. In my presentation, I will give you an overview of these 9 recommendations to explain what are the concepts behind the interoperability framework. These recommendations are split in area. The first area is the establishment of the interoperability framework. The first recommendation is saying that the EOSC interoperability framework should be built using a bottom-up approach. Then it means we have to put in a unique framework all the results related to the interoperability that has been developed in the past years in different initiatives, research infrastructure, so on, in a unique framework. So we are not reinventing the wheel, reinventing something new, but try to put together in a unique framework all the results that we have all around. Then the second recommendation is that the EOSC-IF should embed a library of interoperability guidelines to define these interfaces that would allow the different EOSC resources to communicate. The interoperability guidelines should specify everything that is needed to allow two resources to interoperate, like the API, the metadata format, of the exchange of data that we use it to call EOSC profile in EOSC, and all the process required to really make these two resources working together. The interoperability guidelines should be interoperability guidelines for the EOSC core that would allow third party to federate their service in EOSC, and interoperability guidelines for the EOSC exchange, both horizontal thematic resources that would allow to make two or more resources interoperable. The second area that our recommendation is covering is the implementation of the EOSC-IF. We said the EOSC-IF should embed a set of interoperability guidelines. So we need to store these guidelines in some place. So we need an EOSC-IF registry where these guidelines should be recorded that implement a common metadata structures so we can describe all the guidelines using the same set of attributes. In addition, a technical governance needs to be set up to allow to, I would say, to manage the process to register, remove guidelines from the EOSC registry. Another important recommendation related to the implementation is that the EOSC resource catalog should interact with the EOSC-IF registry, allowing to identify the services, the resources that are compliant with specific guidelines registered in the EOSC interoperability framework. The third area of recommendations, that if the slide will come, okay, is the machine composability. How you can achieve composability in automatic manner. So integrate the resources on the fly, for example, using a machine that can discover some information about the resources, querying some API and so on. To do it, the simple interoperability guidelines are not enough, so we need to enrich them, we need to annotate them with the configuration templates that are other metadata that provide the information to automatically discover and access the services that are compliant with a certain interoperability guidelines. Then the IF should also enable data interoperability. This is very important, allowing that data set can be exchanged between systems. So this means the data can be understood, combined, processed, and analyzed by different EOSC services. Finally, the last set of recommendations is related to relationship with other initiatives parallel to EOSC. We have two recommendations related to the interoperability with the data space. So when we implementing the EOSC interoperability framework, we should coordinate with the data space support center to ensure interoperation between EOSC and data space. And the EOSC initiatives that are working on developing the interfaces that are part or will become part of the EOSC interoperability framework should be involved in the simple open source community to ensure a co-design approach in the definition of the interoperability between these two systems. And finally, the last recommendation about the interoperability with the HPC, then there is the need to develop gateway towards HPC resources to guarantee interoperation between EOSC and the HPC infrastructure. These are the recommendations developed by the task force. These are summarized in this slide. You can get more information, more details in the deliverable when it will be published. I really hope this will happen in the next days. And I'd like to complete my presentation with some information about the status of the implementation of the EOSC Interoperability Framework in the main, I would say, current implementation project is EOSC Future. Okay, what EOSC Future did? First of all, we said earlier that there is the need of governance to oversee the process of proposing and setting guidelines in the registry. The EOSC Future implemented a pilot governance that is running under the project to implement this project. It is currently running this project, this process, sorry. Then EOSC Future also developed the tools to support the EOSC IF. We have the first version of the Interoperability Framework Registry, and this is linked with the EOSC Resource Catalog and Marketplace, allowing to show the connection, which are the resources that are compliant with the certain interoperability guidelines. The third point, the EOSC Future is working on populating the EOSC IF with interoperability guidelines, mainly for the core services, but not only. We also have interoperability guidelines for horizontal thematic services. Okay, this is my last slide. This is showcase the entry point of the EOSC Interoperability Framework Registry in the EOSC platform, and also on the left you can see a list of guidelines that are already part of the EOSC Interoperability Framework Registry. That's all from my side. Thank you for your attention, and if you have any questions.
Thank you, Diego. So, okay, can I invite any initial quick responses? We're going to run 5 minutes over in total over the whole of this session because we started 5 minutes late, but we have just 2 or 3 minutes now for questions. Does anyone have one in the room? Or are there any on Slido yet? Sure, can someone pass the microphone to this row here with the green shirt? Yeah, thank you. Try again, we can start.
1, 2.
Yeah, okay, no, better.
Just a quick question. I think it was already asked before on a similar presentation. The community I work in has already all of its standards that are actually the same thing as the guidelines in the interoperability framework registered in fairsharing.org.
Mm-hmm.
Do we have to ingest everything into the interoperability framework? Because we are sort of duplicating every time multiple steps, and this is an overload to the community.
Yeah, I think this is a relevant question that we received many times. You can keep it. You can bring it home. This is a recurrent question that we received many times. I think there is an underlying misunderstanding. The EOSC IF registry is something different with respect to the file registry. The file. Yeah. Sorry. So since this is not listing standards or listing standards, but is explaining how to use certain standard interface to interconnect services. So it's a bit different. And in any case, you can see, I would say, like a hierarchical structure is a higher level, since is more concrete steps to allow to put together services. This is the main difference.
Thank you. One last quick question in the room. Don't think we have one on Slido yet. Over there, yeah. Keep your hand raised so she can, there you go. People can find you.
Thank you. Can you hear me?
Yeah, not with, I can, but not with the mic.
Can you hear me? Yeah.
Now it's better.
Okay. So, are you anticipating of providing conversion frameworks or converting what the community has to be able to connect to the EOSC, to the standards and the guidelines?
Yeah, okay. What is needed to connect with the EOSC is something that depends by a lot of things, in particular, but depends on the rules of participation. I can tell you what is the current situation. To connect to EOSC currently, the minimum step you have to do is register your resources or your services in the catalog of the EOSC platform. So the only thing that you have to do is following the guidelines to register your service in the catalog, and you are on EOSC. In addition to this, we have another series of core services, like the AI, the monitoring, the help desk. In the current setup, integration with all these services is not mandatory, it's optional, it's up to you. You can check the service. If you are interested to integrate with one of these services, you have to rely to look in the related interoperability guidelines.
Okay, so it acts like the fair sharing then. So initially it is like the fair sharing catalog of assets, things, or whatever you want to list. So that's the first part, isn't it?
We are not the first share is listing standards, is listing articles and so on. We are listing a procedure. It's something different. So we can use the standard you have in first share to interconnect interconnect towards a service. So this means that for example, if you are, I don't know, you have in first sharing a standard to connect catalog, let's suppose. You refer your entry describing these standards. Okay, but if you give me my hands a description of standards, it's not enough to implement something. You need to have a guide that allow you to do it. So it's an higher level.
Okay,
Unfortunately, we will have to close that.
later.
But the good news is, as well as Diego, you have the PI of fair sharing set over here. So I suggest after the session, if you want to continue that particular topic, please do. So thank you very much to Diego. Next, we have, so the remainder of the session is thematic interoperability in the science clusters. And the first speaker from the life sciences is Ludek Matajska from Masaryk University, who will talk about life science login and EOSC AAI. Thank you, Ludek.
Thank you. Welcome. I was already introduced, so I'm using the slide from the e-infrastructure, which is the Czech national e-infrastructure, which is trying to also coordinate the EOSC activities within the country. I would say that this picture, in fact, describes the whole my presentation, because it says what we had before and what we are having now and where we are then moving forward. The first thing, we have a user dealing with individual certificates or individual ways how to register himself or herself to different services, going sometimes through several loops to get there, and being responsible for keeping all this information on his side, and each side had to do the repeated things on their side. And at the end, we have the LS login, which I will be speaking a little bit later about, which in fact provides a single point of reference, both for the user, because it's where it starts, and for the services, because they are using the common infrastructure to actually get things. But before we will get to more details, I tried, so I will try once again. Perfect. Here we see, there we had seen 3 services with all the loop. This is the slide which I borrowed from EGI ACE, which just ended, which has a portfolio of user-facing services in EOSC. And in fact, these are the services which we would like to have connected through some infrastructure which allows us to connect to all of them and do the access control, which is an important part, on all of them in a general way. So this is where the other part of the motivation comes on. We have a lot of services, and we would like to allow users to use them in a unified way from the perspective how they are registered themselves to the system, how they are providing their own credentials. And we would like to have all these services, in fact, not only the life science area, but the whole EOSC, to trust such an infrastructure that what it provides makes sense for them and that they can rely on it. Yeah, again, I have to be more careful. Perfect. So from this point of view, we claim for quite some time that AAI, authentication and authorization infrastructure, is a key enabler for any interoperability. Because without this, we will still have the users fighting with individual registrations, with individual understanding how to get there. And so even if the services are interoperable by themselves, from the user perspective, they are not yet fully interoperable because the user cannot use them in a coordinated way without unnecessary additional effort on his or her side. So what do we have? Here we are speaking about the EOSC environment because I thought that this is important for this audience. When we see the EOSC as the federation of the services, then we need a way how to get access to this federation. And the other thing is, although we call EOSC an open science, we know that we can't open everything. So this is where the whole registration and access control comes from, because we need to keep control over who is allowed to access the data. I'm now not speaking about who is allowed to store the data, but this is just the opposite part of the same thing. But who is allowed to access the data under which conditions? And we would like to make this same for the interface to make same for any service or any data collection, so that the user is not forced to learn for each new collection the ways how he or she presents himself, herself to the collection, what kind of information must collect, whether they trust you, whether they ask for the national identity, some identifier, whether they are asking for passport, whether they want this or they want that. This is something which we think completely opposes the idea of the interoperability. And for the per data, so this is the user point of view, and the service or data point of view is that if they are doing it themselves, they are repeating the same thing again and again. So there is a lot of activities which are completely wasted effort on the side of all the services when they are doing it by themselves. And we would like to provide the front end in front of them to share the common things and allowing the, say, data repositories or services to focus on what they actually need, to define the processes, to define the conditions, to define who, is allowed to use it, but not to do with the technology behind and with all the thing of collecting this information together. Was I successful? Perfect. This is a slide which I used just to ask ChatGPT what the ChatGPT considers as key concept of the AI in the context of the interoperability. So I'm keeping it here. I will not, and it makes a lot of sense of what the ChatGPT found. And if you look at it, you will see that this really covers all the aspects which we expect from the AI as the key enabler for the interoperability. And one thing which I will emphasize is the last but one, and this is the trust, security and trust. Because for the AI, you need to build trust. It was already mentioned in the previous session, not the previous presentation, but the previous session, that if we would like to build sustainable services, we have to be able to trust that they will exist. And for the AI, it's even more important, because if we say that the AI connects all the services and then expose them to the user, then we have to make sure that the services trust the AI, that the data are provided properly, and we have to make sure that the user trusts the AI, that it is using the data the user provider, and together they have to trust that the AI will be with us for long term. Because otherwise it doesn't make sense, because then they will have again to repeat the same process as they did with these separate services. This is the ARC blueprint architecture, which was devised quite some time ago as the input to the AAI at the EOSC level. And one thing which we did within the Elixir and now within the whole life science community is that since the beginning we contributed to the setup of the ARC blueprint, which was otherwise say prepared under the auspices and coordination of JANT within the series of ARC and ARC2 projects. And we contributed, and we also made sure that what we did is fully compliant with this blueprint, so that it really serves as an example of say implementation and also of the validity of this scheme. And the ARC blueprint architecture actually defines how the connection between the user and the way how the user registers somewhere once at most, and how all the services are able to get the information they look for, and how this whole can be trusted because the individual components can be, or the whole can be in fact certified if needed. Perfect. From this came, from the ARC blueprint, there came the EOSC AI Federation. You see it, it's again, this is a slide which is borrowed from the EOSC Future project, and this says that we see the EOSC AI as a federation of community and other AIs. So again, for the interoperability, that there is no one ring which rules them all, but that we have a federation. We are within Europe, so we love federations. We have a federation which is able interoperably work with the AI information among themselves. The basic is the ARC blueprint. Now there is a new ARC blueprint which actually defines this federation infrastructure and the say the interaction and interoperability between these community AIs, and the LSAI. Oh, again, I forget to put it. And now we are getting to the life science AI. The life science AI was produced within the EOSC Live project, but it started previously. It has as a legacy the Elixir AI, which was just one large research infrastructure. We went beyond that, and we see how many research infrastructures were involved in the EOSC Live project. But they, in fact, agreed to gradually adopt the life science AI as the basic, not the unique. We are not having a monopoly. You still can keep your local registration, but at the unique way, and we hope that we will be able to convince all the communities that at the end it makes sense that all their services are connected to the LSAI, and that the user, if has the LSAI identity, he or she will be able to access any service within this whole ecosystem of the life science. Last one. Yeah, last one, okay. So this is the, if it is last one, then I will say this one, because I have three more, but
I protected this.
This is the, okay, I will get to the last. Yeah, when I said that we have, this is the point, we have Elixir AI, we have Eurobioimaging, we have BBMRI currently covered by the LSAI, and so we are progressing, and we have services from other life science research infrastructures. So we are really moving to this, and you will have the opportunity to see this, and I will just show the last slide when I will be allowed to do. Future evolution, yeah, this is the future evolution. Two things, trust building, both at the sustainability, and this is the summary. We say the AI is the key enabler for the interoperability. We have LS login or LSAI as this is the front end for the LSAI, as the representative of the EOSC community AI, and we can demonstrate all the positive points of the shared AI. We have adopters, and we have quite some challenges ahead of us to actually expand it further.
Thank you very much, Luda. So, the most popular feedback so far via Slido is perhaps you could clarify. So the impression is given to people who obviously are not closer to this, that here's another AAI system, and they're saying, why do we keep seeing what to a wider set of users might seem to be a new AAI system? Can you clarify that they're all working with a common framework and how they fit in with the EduGain Federation?
Yeah, there are two things. One is what I said, this EOSC AI Federation, which defines that we can collect things together. And the other is why we have these individual pieces. And that's where that communities, and it makes sense that these communities are large enough that it really pays off. So like the whole life science community, they may have special requirements. Within the life science community, the special requirements which are shared among most of them are the access to the sensitive data, which imposes some requirements on the AI, on the attributes, on the trust on the AI, which may not be shared, say, by the high energy physics community, because this is not working with so sensitive data. And we already discovered within all this collaboration that trying to find a common denominator on too large base slows the process to the moment when the services are returning back to this individual solution per service. So that we have to find a balance, and exactly this interoperable federation of EOSC AIs is a way how we see the option that if there is a community which has a very specific needs, which may be propagated to the mainstream in the next 2 years, the federation allows them to start now to provide their own solution using this standard like ARC blueprint to make it fully compliant with the rest, but to allow them to be different if they need it. And eventually this may become a mainframe, or eventually they may not need these special features. And this federation can disappear, and this piece can disappear and be replaced by something which is larger scope. So this is the evolution support within the interoperable environment.
And we have time for just one last question at the back. Just while the mic goes there, let's just clarify, there is a family of EOSC AI implementations in different domains which are using a common ARC blueprint, a common framework, just because not everyone will be clear on that. Yeah.
Thank you very much for your presentation. My name is Andrea Scharnhorst, and I work for the DARIA ERIC, which is an ERIC in the digital humanities. But I have been also a statistical physicist in my past, yeah? And could you give us any kind of order of magnitude of how many services? I don't need concrete numbers. I just need to say it's a couple or tens or hundreds you think you can integrate by this step forward. And could you also specify the order of magnitude of the user communities? Because in the humanities, we often have the problem that it's very heterogeneous, not easy to count whatsoever you wanted to count. And I'm just curious to see if the life scientists have a better statistical view on the background.
In the worst, my colleague Jana will correct me, but the user base of the LSAI at this moment is something like 14 to 15,000 users and several hundreds of services. So so this is the scope of what we have within the LSAI, and our idea since the beginning was that we have to be able to cover hundreds of thousands of users and say thousands of services. That's the scope we are working with.
Okay, thank you very much, Ludek. One more round of applause, I think. And so last but one speaker is Mari Klimola from Tampere University and CESTA. And she's going to talk on the SSH Social Sciences and Humanities Conversion Hub. Thank you.
So thank you. Okay, let's see how this works. Okay, great. So I'm going to talk about Conversion Hub. That is an example of an interoperability solution in the social science and humanities, and it's something that we did in the SOC project. So many of you might be familiar if you are not. So shortly, SOC project was something that started already in 2019, ended last year. And now post-project we are organized as SSH Open Cluster, but there's no ongoing project at the moment. And the SOC SSH Conversion Hub was part of Work Package 3 in SOC project. The work was led by Clarin, and we had all the SSH infrastructures there. Oh, I'm sorry. So we had a really simple use case. We imagined a research team that has found metadata or data that is in a format they are not familiar with, so from another discipline within the social sciences and humanities, but that's, I mean, it's a very diverse community. And they want to integrate the metadata or the data with their own data and with their own workflow, with their own analysis. And optimally without too much manual work. Although I will say that in the SSH sector we are very used to doing manual work and manual analysis and all kinds of spreadsheets and you name it. So that's what we just do. But this was our starting point. So it's nothing too complicated, right? Well, wrong. I'm sure this audience knows this. Yeah. And we started. 2019, so some of this is already outdated, but I think the main principles are still there, and then there's a lot of work being done in the interoperability landscape within EOSC, and things are moving forward. Maybe not as quickly as we'd like, but I think the basics things still stand, even though this started in 2019. So there's a huge number of metadata formats and controlled vocabularies, ontologies that are reused within SSH only, and then if you think about other disciplines or domains, then you get them even more. So we know this. Everybody wants to have their own metadata or data format. Well, I'll say data formats are more restricted, but metadata formats, you name that, there's a huge number. And there's a lot of mappings, mostly in spreadsheet tables. I think we are moving forward there, but still it's very much spreadsheet based. And researchers, they are not really interested in this. I mean, they are doing research, unless they are doing research on metadata formats, and that's a different story. They are not, or they were not, readily available conversion services or solutions. I don't think this hasn't really changed there. This is just something that is not there. And one of the questions is also that you need to recognize when you need a conversion service or solution when you're using data from other discipline or domain. And when you actually, what you need is a multidisciplinary research team where you have the experience, where the humans have the experience. So I think these are a couple of different use cases, and you need to really be careful what you think what you need and what is needed. Anyway, we identified different kinds of existing conversion solutions in SSH. So there are some ready-to-use web services. You can go and just feed your file there and get something out. And then there's the installable software. So basically things like a social scientist might be using SPSS and then just save as CSV file, so export files from a software. And then something we call complex solutions or recipes. So basically guidance or best practices, multiple steps to be taken to get from one format to another. And then these are usually very unofficial guidance. They live somewhere and are not very stable, not sustainable usually. And we do know that researchers would really benefit from automated conversion paths, and many of these could be automated. So this was sort of the starting points for the work we did in SOC. And this is what the conversion hub looks like. So it's a simple web user interface it's based on Drupal. There's an API, so it's machine actionable. And we have some 40+ conversion solutions described, curated. So this is a metadata about conversion solutions. And in the Work Package 3, we also created some conversion solutions that was part of work, and they are described here in this. So 40+. We did have a much bigger list in the beginning, but it turns out that there are so many solutions where you don't know the license or the owner or if it's maintained or not. And we didn't want to include those. We wanted to have very clear cases here. But it's huge. The landscape is just overwhelming. So we have 40 plus solutions, and they are, we really try to focus on cross-community solutions, but most of them are from Sesta Clarin and then cross-community. And another finding here was that the expected level of knowledge needed to use these solutions is usually quite high. So we really don't expect a sort of normal social scientist, for example, to really use these. So they need some sort of data manager maybe to help them or to support them to use them. So that's not very helpful for the researcher who wants the data now and has a burning question and needs answers. So the conversion hub itself, it's, we hope, really interoperable. So we did create a data model for it, but it's all these attributes are from existing things like schema.org and SOCRO, and which is and the structured metadata is exposed via the API, and this is also interoperable with the SSH open marketplace. So actually something. It might be ingested with the marketplace easily enough. So a few conclusions. So each of the SSH communities have their own established traditions and customs, and well, then we have interoperability issues. And the metadata mappings crosswalks are typically on something I would call the study level, so a high level, not much granularity there. So if, for example, in social sciences, if you usually work with variables, so that metadata is, well, not non-existent, but not necessarily interoperable at all. And I think the existing diversity needs to be accepted. There's a reason for that. But at the same time, we are not as unique as we like to think we are. So somewhere in between, that's the optimal level. And for some of these solutions, really adding documentation, adding licenses would be enough, so that they would be much more useful and could be automated and be in the workflows. Yeah, but the ownership really, I mean, please use licenses. There are a lot more interoperable solutions within the research infrastructures. This is just one that we created, and we run into some issues. Originally, for example, we thought that we could integrate this with a switchboard, that's a Clarin product where you can invoke different things. But I mean, this is we didn't have enough resources for that, and so this is where we are now. And you can read the deliverables. And thank you.
Thank you very much. Okay, I invite a quick question or so in the room so far. Still waiting on Slido. Yes, thank you.
So Heinrich from DKC in Hamburg. So this is, thank you for this interesting presentation. So okay, so Heinrich from DKZ in Hamburg. So thank you for the presentation. And so this issue of conversion and mapping of metadata is so it's very, very common. And for example, in climate research, we have the case study. So where we want to use to mapping from metadata, one metadata schema to the other. So we want to use the fair core for EOS metadata and crosswalk registry. And this is very interesting because more or less you do here the same with your conversion hub. So my question is, can you imagine that we can use this conversion hub as well as for other domains? So it's not domain specific, not only for shock, or vice versa, that you use as well this EOSC component that are just developed. I don't know if you know this registry, Messi, yeah?
Yes, thank you. So the conversion hub itself, it's just domain agnostic. So we have a data model that you can use to describe the solutions that you have. No problem. When it comes to all the developments within EOSC, so as I mentioned, the SOC project ended already 22. So a lot has happened since then, and we really don't have the resources. We have the resources to maintain the conversion hub as it is, but not development resources. So that's something to follow up.
Okay, and the last question, Bjorn here.
Are you interested actually, so this is currently a registry, right? You cannot run those tools in this conversion hub, or can you? Would you be interested to integrate that?
Yes, and I mean, one of the things was the integration with the switchboard would have been a step towards that. So yes, I mean, really getting these into the workflows and automated workflows and analysis workflows, that would be the long time goal, yes.
It can be a short-term goal. So 5 of your tools we already have, and we can just add a link, and then people can run that on public infrastructure.
Okay, yeah. And I will also add that one of the things was that we looked at accessing the data, but social science humanities, there are a lot of access restrictions. So that's also where AI solutions would be useful to have integrated all of that, so you know that you can access data automatically.
Right, let's thank Mari again. Thank you very much. Okay, the final speaker is Daniel Bayo from the National Institute of Geophysics and Volcanology, and he, I am assured, is in the Zoom room, and we are ready to begin. He's going to talk from the ENVRI cluster on data and services interoperation framework for the environmental sciences. Over to you.
Thank you so much, and good evening, everybody. So allow me to extend the screen.
You're a little quiet in the room. If you could just speak closer to your mic. Thank you.
Should I speak louder? Can you hear me?
That's okay now. Thank you.
That's okay. Okay, good. So I assume you can also see my presentation. Let me go in presentation mode. Does it work?
Yes, you're good to go.
Oh, great. Okay, so thank you for inviting me in presenting the work that we did in ENVRI about the data and services interoperation framework in the environmental sector. So first off, I would like to start by providing a snapshot of what the ENVRI community is. So the ENVRI community aims at studying and monitoring the entire terrestrial, solid earth, marine and atmosphere ecosystem. And it's made up of 27 different research infrastructures, both single domain and multi-domain, that work on these four main domains. Let's say that the slogan is basically that the Earth is our lab. And that's why we have, so the first goal is improving the understanding of the entire system Earth by putting together the data and services from all the research structures in those four domains just mentioned, and harmonize the delivery of the observational data. So it's not just about making science with the data we have, but also working a lot on the technical and data side, if we wish, for making the data more fair. Of course, it implies collaborating, setting up collaboration frameworks among the research infrastructures, sharing the knowledge, and also develop common solutions and learn one from each other. This would eventually not only improve the way and the quality of science that we produce, but also avoid unnecessary costs and duplication of effort, which is something that is not uncommon in the so-called long tail of science. Also, one of the goals is moving towards interoperability with the European Open Science Cloud. Now, ENVRI was built through the years in different ways, so at least by 3 different projects. Then it's now set up not really as a consortium, but there is a group of people meeting periodically for elaborating strategy and taking decisions in a common way for the environmental cluster. And so this is where we are after more than a decade of collaboration. And now ENVRI is basically leveraging uh, the, the efforts done by the single infrastructure and collecting and wrapping the low-hanging fruits by participating to international initiatives. One of the key achievements of ENVRI is the ENVRI Hub. As we see it, it's the central gateway to the European environmental data and services. Through this gateway, the dataset is supposed to be interoperable, and we basically have produced four different, let's say, services or elements that would improve the interoperability, the openness of the data, and also of the results of the processing made over the data. So the first one is the EMRI catalog of services that I will show you in a minute. The second is the EMRI knowledge base that enables those who access to this area to access to all the practices, to the common data service requirement that facilitate basically the making science and environmental clusters. And also contributes to setting up the interoperability framework for tackling common challenges. Then we have the EMRI training gateway, so it's more on the training side, meaning that that's also interesting, I think, because making interoperation is, of course, we start with technical level, but as we widen and aim at doing something that works for a huge audience of scientists, then we also have to take all the training and sharing of information. So that's why we also have the training gateway. And finally, we have the Embrace Science demonstrators. This is something which is very close to the computational world. So it means providing interactive data science and scientific computing notebooks, which helps sharing the information, the practices, but also that supports the data, the repeatability of results. Now, I would like to show you what we have done in one specific element of the EMBRI Hub, which is the EMBRI catalog of service. So the EMBRI catalog of service concept is very easy. There's the entry point for accessing the data services provided within EMBRI, and it's done both by a user interface but also through machine-readable APIs. So the EMBRI catalog of service describes and provides access to all these resources, and so is supposed in this sense to be an interface to the wealth of services and datasets provided by EMBRI. An interface for everybody, but in this in particular, as it was developed in the context of EMBRI Fair, for interoperating with the European Open Science Cloud. What I'm presenting, leveraging the work done in one specific data infrastructure, which is EOSC. You have the link if you want to access those catalogs and have a look at the actual results online. So I don't want to describe the details of this user interface because let's say that it's quite common. So you can search the resources by several filters, type domain keywords, and then once you have the results, you can access the documentation and also access the APIs so that you can programmatically access in a machine actionable way to the web APIs that provide access to the datasets of the infrastructure that is provided. Now, what I would like to share with you are some key concepts over interoperability. So, in the previous presentations, we discussed about AAI as a key to the interoperability, which is something that we should agree with because it supports, let's say, the more infrastructural part of interoperation. What we addressed in our case is the hard interoperation across a huge heterogeneity of data and datasets. So the architecture we relied on is based on a 3-tier architecture. So on the bottom, we have the data sources that provide access to datasets by means of web services. Those web services are described in a common standard, namely EOSC-KP, and stored into a catalog, which is part of this core data access system. So the metadata catalog is based on the serif standards, and together with the semantics and the web service access, it basically provides homogeneous access over heterogeneous research infrastructures. So it basically means that by means of the APIs on top of the core data access system, anybody can access those services. Okay. So yeah, the work done on the metadata was quite demanding. We also worked on the semantic side, which is one of the keys of the interoperability, as also highlighted by their principles, so to provide the semantic crossroads to different web service parameters. So, what was the role of the empty catalog? Somehow we've already explained it, but I would like to go into detail. So we have modelized, let's say, so the data sources, the bottom right corner of this slide, as a three-tier system, having data, metadata describing the data sets, and two ways for accessing those data sets, both by portals for human accessibility and by means of APIs for machine accessibility and machine actionability. So for us, these are the requirements of the data sources for being able of providing access to the data sets through the catalog. If this is the case for research infrastructure, then by using the catalog, the semantics, and the web APIs approach, all these resources can be registered and stored in the empty catalog, and in turn can be accessed by external agents like the European Open Science Cloud. So some work has been done in this sense. Where there are ongoing discussions on the current European Open Science Cloud profiles, and I think that the work that has been done up to now needs to be also improved for being perhaps even more ambitious. So not just providing a catalog of available resources, but perhaps to put them together and make them really accessible to potentially through a single interface. So in a word, I would say that this catalog may allow the interoperation with the research infrastructure assets in general, meaning both data and services from the environmental cluster. Now, currently, the empty catalog is provided by the task force. Was provided at the time in the framework of Task Force 1. It contains more than 55 assets, including several research infrastructures in the environmental domain. I just mentioned some of them in this slide. The APIs to access this catalog are publicly accessible, so that's something that can be already leveraged up to now. And this can be consumed by any consumer for different purposes. So we have yeah.
Sorry. Many apologies. We need to complete the presentation, please.
Yeah.
Can you show your
very
last
done,
slide?
right?
Thank you.
It's the last slide. So I think that in the environmental cluster, we have demonstrated the interoperability across multiple research infrastructure and environmental clusters, but of course the key challenge is the metadata. So it means better description of the research structures. Also, complementary to what has been said, we have implemented a single sign-on and by following also the blueprint architecture. And now, so on these two tracks, I would say we are full speed. We need to improve, but what is lacking at the moment is that it still needs to be supported by a clear governance frameworks for achieving interoperability, because of course different research infrastructure have different governance. And then I'm done. Thank you, and apologies for taking more than time provided.
Okay. Thank you. Right. Probably time for one final question in the room. Does anyone have a question they would like to put to the speaker? I am checking Slido as well. If we don't, then we can say thank you to all the speakers. I hope you've got an idea of the range of work that's happening in the science clusters to enable thematic interoperability and the work we have to do to fit that into the recommendations from the EOSC-Association Task Force as presented by Diego and the services in the EOS core. Thank you to everyone. Final thank you to our presenters. And thank you, Daniel, online. Thanks for your help. That was challenging.
You were excellent.
What I should have said is we have